Hello everyone, welcome back to the second video of this tutorial series. In this video, we will finish our AWS setup and start with the deployment. So without any further ado, let's jump right into it. In last video, we saw how to create a database in AWS and a cluster in ECS and a repository in ECR. Also, we need to connect this database locally. So for that, we need to modify one thing. Go to your database, go to your VPC security group, which we have selected is default. We need to edit the inbound rules. Since it won't allow any traffic or any IPv4 to access it, we need to modify the inbound rule to make it allow. So we'll delete this rule, add a rule, and for now we'll give, since it's our Postgres, we'll give PostgreSQL and we'll allow anywhere IPv4. Since it's for demo and testing purposes, it's fine. If you want a custom rule, you can add that a custom IPv4 and it will work then. So we save our rules and it should be up. Now if you connect it via the URL provided in AWS, it should work. So let's go back to our ECS. Now what we have to do is create a service inside our cluster which will execute our tasks. So basically your task is nothing but for a certain set of commands that fetch your image and execute them. But to run that task, you need a service. So service runs a task. So you have a cluster. In a cluster, you can have multiple services, and inside a service, you can have multiple tasks. So for now, we'll only focus on one task, which is deploying or running our server. So if we, last time we saw that we need a So for this we need a task definition. So we need to go to our go to task definitions and create a new task. So for this we actually need a role type. So to create that, we'll go to IAM. So here we need to go to roles and create a role. So here we need to select AWS service and we need to choose for Elastic container service, and here we need a container service task. Basically this is the use case that we are looking for. So we go to next, and what we want is task execution policy, role policy. So this is what we need. So this will basically allow your tasks to get executed into EC2 instance. And unless you do this, it won't have permission to execute those tasks. So this will allow the permission, or sufficient permissions are granted. So go to next and give it as AWS ECS task execution role, so that you understand what your role is for. Create it, and now we go to ECS. We create a task definition, and now this should work. So now we'll give it a name as Enigma task, and we'll select the role type that we just created. Network will be bridge. Here again select the same role, and here is where we'll connect our container to our task. So add a container. Container name will be Enigma container, and image will be the image path that you have in your ECR. So we are going to paste it here, and the tag will be develop. So this is the tag that we will be pushing with, but you can use whatever you want. And we'll provide a hard limit of 1000 and a soft limit of 500. This is just for limits, it doesn't matter. So our port mapping will be 0, will be the host port, and container port will be 8080. This we will be explaining once, this I will be explaining once we create ALB. So that is when this will be needed. Rest we don't need anything. Container timeout, nothing. And we'll just configure auto. So this will allow us to get logs into our containers. So just enable it. If you don't want logs, you can disable it, and we'll add this container. So now we have our container. You can see the URL, and that is it. We don't need to do anything. We'll just create it, and the task definition has been created successfully. Now go back to your cluster, open your cluster and create a service which will be of EC2. See, you already have selected Enigma task, which is the first latest. So every time we will push, this task is what will get updated, and that will trigger a new service run. Service name will be Enigma-service, and health percentage will be 0 to 100, and number of tasks will be 1. This is where we'll tell that we only execute one task. And I guess here everything is fine. We'll go to next step. So here for now we will not select load balancing. We'll keep it none, and we'll go to the next step. We'll go to the next step, nothing to do here, and we'll create the service. So we'll see a service, and you see it started deploying the task that we had just created. So here in the logs, you can see the logs. Since it doesn't have any logs, you won't get anything. And in the events, you can see what it is doing. So you can see Enigma service has started a task. So now, for now, we have completed all our AWS requirements. Let's jump to code and see how we will use these tasks and service, and how all of this comes together. Open any of your Spring Boot projects and follow the steps to deploy. The first thing is to go to our root project, and we will basically create a new file named task-definition.json. So now head to your AWS ECS clusters page and go to your service. Inside service, go to your task. So here you can find the JSON file that we need to add. So this JSON file is nothing but the revision that we will be creating for each deployment. There won't be any change, but a new task is required to trigger a new build in our service. So that this file will take care of. So copy this and paste it in your new created file. So I have removed few things. You can go through this and remove them. Few of the things are unnecessary, which have no meaning, and they are simply adding to the whole size of your file. So go ahead and remove them, and let's go on to the next step. So now after creating your JSON file for the task, we will create a workflow, that is our pipelines YAML. So for that, we'll head back to our root and create a new directory and name it as GitHub. Only if I can type. Inside this, we'll create a new directory called workflows. This is where in this directory all your YAML files will remain, whichever you want to execute or whatever you want to execute on the GitHub Actions. So open this and create a new file called pipelines-develop.yaml. So now what we need is, we need to add the definitions of each and every task that the steps that we want the GitHub to execute, basically the GitHub Actions. So we'll see that now. So the first thing that we need to add to this YAML is the name. So we'll add the name as build and deploy to AWS. So that is what we are doing. Next, we want to tell on what push or pull what we want to do, basically which branch or which action we want to execute. So for that, we will write this. So basically this will tell the GitHub Actions that on push, on which branch I want to execute my particular YAML file. So next we will define is jobs. So basically we can have multiple jobs in a single YAML file. In this case, we only need one job that will do everything for us. So our job name will be setup, build, publish and deploy. Since we'll set up our repository and our build, and then we'll build the Docker image, publish the Docker image to the ECR that we had created, and then finally deploy that image to our cluster. And here we have kept this check so that it only executes on our main repository, not on the fork repositories. we give this a name, and then it runs on Ubuntu latest. So that is the Linux system that the whole execution will happen. Next, what we need is to define steps. So the first step will be to check out our repository. So our repository will be automatically checked into this particular virtual machine that it will create. So here is where you provision your virtual machine basically. It's not exactly a virtual machine, but it's like a virtual machine. So next we need to set up our Java. In this case we are setting up JDK 1.8 and we are using 1.8 version. So now we are calling in Java setup for this, so that we need to build it. So in next case what we'll do is build and test with Gradle. So here in this case we are testing and building with the Gradle. So this will generate our package, which we will be including inside a Docker image. So the next step will be to configure our AWS credentials. So now what we do is we configure our AWS credentials, and we have to provide our access key ID and our access key secret inside our GitHub account. So that we'll see next what to do. After this, we need is to log into ECR. So this will automatically happen with the action that has already been written. So these actions are already been written, we don't have to do anything. It will automatically log us in based on the credentials that we have provided here. Next step is to build, tag and push the image to ECR. So here we'll do all three things in one go. We'll call in our ECR registry, which we will be getting from above configurations, and we give the image tag as develop here, and we tell the repository name. So basically this will be the repository, ECR repository URL, that is a generic URL. Inside you can have multiple repositories. Inside that you can have multiple tags. So that is why we define all three: registry, repository and image tag. Next we'll build it with the variables that we provide, and then we push it to the link that we have gotten from our environment variable, and this is how we build and push. So next step is to push the new image to ECS task definition. So here is where we'll update the ECS task definition, and the file name that we will be telling that we just created will be called upon here. So this will create a new task in our task definitions. So the next step is to actually deploy that task. So that deployment will happen via this particular action. So this will call upon our task definition, which we have generated here or tagged basically here into an image, and that image is getting into this particular step, and we are telling a service that which it needs to target and the cluster, and this will tell that the service needs to wait, or basically the GitHub action needs to wait till the service is deployed or it's stable. Till then only it will be finishing these steps, else it will fail if it will not get deployed. So let's see how to create our AWS key and access key. Now to create your access key and secret, head to IAM, go to users, and we don't have any users, so add a user, give it a name admin, and provide an access key to it. Go to permission, no permission boundaries, attach existing policies, and once we need admin access, we need a container registry full access, and IAM user change password. These three policies is what we will be attaching to it, and we'll go to the next. We don't need any key or anything, and we'll create the user. Now this user has his access key and the secret key. So what you need to do is you need to copy this, and you need to head to your repository, go to settings, and inside settings you'll have secrets, you'll have actions. These secrets will have actions, and here all you need to do is create a new repository secret and give it the name that we had just given here, and paste the secret. So we'll first paste the secret, and since this is your ID, we'll add it, and we need to add our access key as well, which is hidden. So you can do this and I will not do this, and you can do it the same way that it was done for the key ID. Name it access secret key. This will be the name for it. So that's it for this video. In the next video, we will deploy it to the AWS using GitHub Actions and test out what we have done. And also we'll create the application load balancer and we'll see how to integrate it with the AWS. Thank you for watching this video and see you in the next one.